everyone. So I'm going to do a little bit of a review here, going through chapter 6 to kind of help you prepare a little bit for the chapter 6 test. So I'm just going to go through section by section, cover some of the main points in each section, and then go through some examples about those. So section 6.1, we talked about factoring out the greatest common factor, or the GCF, and then also factoring by grouping. And that's generally when we have 4 terms, okay? So look for grouping when we have 4 terms. But we started off 6.1 going through some questions sort of like this, right? When we had, just an expression and we just needed to factor it. So in this case, I would be looking for the greatest common factor. So, you're looking for numbers, something that goes into 24 and 18. And the greatest number that goes into both 24 and 18. And again, you can look at these and kind of break them down. You can break them down into kind of what I would call a product of primes. And then look that way. So 24 would be 2 times 2 times 2 times 3. And then 18 is 2 times 3 times 3. Well, these each have a 2. And they also have a 3. And then we know that 2 times 3 is 6. So if you really want to, do it the long way, that would be one way that you could do it. We could take out a 6. And then we notice that this one has an x squared and this one has an x, and we always do the one with the least exponent. So we take out an x, because I can't take out an x squared because this one only has an x over here, okay? And then we can take out also a y to the third. They both have y to the thirds. And you can do that by, if you want to factor, you can actually divide these. So you can divide both of these by the greatest common factor. And I'm actually going to rewrite that. But then when I divide, I basically, in this parentheses, I have what's left over. So 24 divided by 6 is 4. X squared divided by x is just x. Y to the third divided by y to the third is nothing. So that is done. And then this one, 18 divided by 6 is 3. X divided by x cancels, and y to the thirds cancel. So this is your completely factored answer. All right, so let me do another example here. Let's do one where, let's see. So we'll call this was example 1. Let's call this one example 2. So if I have something like 5x to the third minus 10x squared minus 2x plus 4. So this one has the 4 terms. So that's what I'm talking about by grouping. So what we do is, we're going to group 2 terms on the left together, put them in parentheses, and then group the 2 terms on the right together and put those in parentheses. Just be careful of the signs. This was a plus 4. So when you distribute the negative, you also want it to be plus. Negative times a negative is a positive. And so we're going to factor each of these 2 parentheses separately. So this parenthesis, we're going to be looking for a GCF. Well, that would be 5x squared, right? And left over, so we can divide those kind of either off to the side if you want, or in your head, 5x to the third divided by 5x squared would just leave us with an x. 10x squared divided by 5x squared just leaves us with 2. So that's factored. And then out of 2x minus 4, I can take out a 2. So then I'm left with x plus, or sorry, not x plus 2, just x minus 2. Sorry, gotta try to be careful here when we do this, because you want the sign to match the original, okay? Just imagine as what we did in this step, we didn't really do anything. We just put the problem in parentheses, okay? When you distribute here, you still want this to be a plus 4. -2 times -2, it's +4. Now that we have kind of common factors here, I can put those common factors together and then put the things outside of the parentheses together. And that is now completely factored. And I'll just note here that it doesn't matter if we write it like x minus 2 times 5x squared minus 2 or 5x squared minus 2 times x minus 2. Those still mean the same thing. Okay, so these two mean the same. That's the same thing. And then one more example here. If I have, let's say, 11a squared b plus 5c to the third. Okay, let's go ahead and factor that. We actually notice here that, well, there is nothing to factor, right? There are no common factors here. 11 and 5 don't go into each other. A squared and b, well, I don't have any of those over here, and then I don't have any c's over on this term. So this one, you know, our GCF here is actually 1, which means that this is prime. Okay, it cannot be factored anymore. All right, let's then go to section 6.2. Okay, so section 6.2, if you guys recall, that was on factoring trinomials. Oops. Trinomials. Okay, and we only did them when it was x squared plus bx plus c. So this right here is a 1. So when this is a 1. So when a, you could say equals 1. And then section 6.3, we did it when it was ax squared plus bx plus c. So anything besides 1. So let's go ahead and do some examples. So the instructions here, I'm going to say we're going to factor completely. Okay. So example 1. So if I have x squared minus 6x minus 40. Okay. What I had taught is we are going to take the 1 and the negative 40, or just the negative 40. So when you just have a 1 here, you just are looking at this end term. So we're going to take negative 40. Okay. And we need, so we need factors of negative 40 that add to the middle number, that add to negative 6. Okay, so what we could do is we could list out all the factors of 40. I'm not going to worry about negatives at this point. So 1 and 40, 2 and 20, let's see, 4 and 10, 5 and 8. Okay, so those are all the factors of 40. Now what do I mean? Need factors of negative 40. So they multiply to negative 40, right? That add to negative 6. So one of these has to be negative, one has to be positive. Okay, and if you want to, you can keep going. You can write down this list again. And because it has to be a negative 40, either these have to be negative or these have to be negative. So we look at, well, what works? What makes a negative 6? Well, it would be 4 and the negative 10, right? Because we know 4 plus negative 10 equals negative 6, right? So once we have those, once we identify that, it's really easy. We just put it in parentheses, x squared, right? What are factors of x squared? Well, it's just x and x. So that just breaks up like this, x and x. And then we had a positive 4 and a negative 10. And that would be your factors. And again, what we could do is we could check this, right? So we could check. How do we check? Well, we would just FOIL, right? So we would FOIL this. So we check by FOIL, right? Which is our first outside, inside, last. So we would multiply the x's. That's our f. We would multiply those. So we would have x times x. And then we would have plus x times the -10 plus 4 times x, they're inside terms. That's I, and then our last terms, we would have plus 4 times -10. So we'd have x squared, x times -10 is -10x, 4 times x is +4x, and then 4 times -10 is -40. These two are like terms, so I combine those to be -6x, and it matches. So that checks out. All right, let's keep going. Let's do another example here. So I'm going to call this example 2. We have y squared plus 9y minus 36. All right, so again, my leading coefficient is 1, so I just need factors of -36 that add to 9, and that's going to end up being, so again, if you need to, you can list out all the factors. Okay, list out all the factors of 36. If that helps you, you could even do it again, right? But in this case, I'm going to see that 3 and 12 are going to make the negative, are going to multiply to be -36 that add to, so they multiply to be -36, but then 3 plus 12 equals 9. 3 plus 12 equals 9. So I'm going to break it up like this. And I have y minus 3 and y plus 12. And again, we could check that. I'm not going to do that because we did last time. And then our last example for section 6.2 is this one. Let's say a squared plus 6a minus 36. So again, I'm looking for factors of -36 that add to 6. So I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Okay, and again, if you want to, you can write all those down again. Okay, write all those down again. Oops, well, I'll just do 6 and 6 and then 4 and 9. But we would, we would have to make one of these negative here. But does any of these add to +6? And if you go through this list, they don't. So there are no factors of -36 which add to 6. Hence, this is prime. Our greatest common factor is 1. All right. Between all of those, right? And we can't do anything special with that. So let's keep going. Let's go to section 6.3. And in section 6.3, we did trinomials. Oops, trinomials. Sorry, let me rewrite that. Trinomials that looked like ax squared plus bx plus c. So this a is not 1. So anything but 1. Okay, and we really learned two different methods here, or one was a book method, one was my method. My method was that we would split the middle term. So split middle term, right? So split the bx in order to factor by grouping. And the reason why I do that is just so I don't have to basically guess and check, which is the other method. And we're not, we're not learning anything new. So method 2 was basically trial and error or guess and check. And that's what the book wanted you to do by reverse FOIL. Reverse FOIL is what they called it. Okay. But this is the one that I'm going to recommend. Okay. So for example, okay, and let's again, I'm going to write the instructions here. Let's factor completely. Okay. So let's do 3x squared minus 8x minus 28. Okay. So in this case, what we do is we take this and this. So we take a times c. Okay. A times c. So we do 3 times negative 28. And I need a calculator for that. Well, it's definitely give me a negative, but it's going to be equal to negative 84. Okay. And then we're looking for factors of negative 84 that add to negative 8. So 1 in 84, that's definitely not going to work, by the way, obviously, but I'll just write it down anyway. 2 and 42. Let's see, does 3 go into 84? Sure, it does. Okay, so we have 3 and 28. 84 divided by 4 is 21. Just keep going down the line. 5 doesn't work. 6, I don't think. Oh, yeah, actually it does. And then anything else? Let's try 7. Yeah, 7 and 12. And then, nope, 8 doesn't work. 9 doesn't work. Obviously 10 doesn't, and then 11 doesn't. So these are our factors. And we want them to add to negative 8 to split this middle term. Okay, not to be our final answer, okay, but to split it. So to add to negative 8, it would have to be these guys. So it would have to be the 6 and negative 14. So I'm going to take this. I'm going to take this guy and I'm going to split it into the 6x and negative 14x. And then I just rewrite everything else that I have. And now once this is rewritten, now I'm going to group it. And again, if you know, or if you are more comfortable with, factoring by trial and error, please, by all means. That's actually the way that I learned it when I was in school. I use this way now just because I just think it's easier. But anyway, so now what we do is we factor what's in parentheses. So we take out a 3x, that's our GCF here. So I have x plus 2, is left over. And then take out a 14 right here out of 14 and 28. And again, I'm left with the x plus 2, noting that I have to have the original negative sign here when I distribute negative 14 to 2. And now the x plus 2 is our common factor, right? So this guy and this guy, I combine that as just a single x plus 2, and I have the 3x minus 14. And that's the answer. And again, the other method there would be trial and error. I'm not going to show you that because that's not how we're going to do it. Let me just extend this a little bit more. I'm going to need a few more pages. All right. I like using the Word documents. For me, it's just easier to be able to go back and save this afterwards once I make some notes. I know some people like to use just like the notepad or whatever on their computer apps. But anyway, Next section is section 6.4. We went through some factoring formulas here. Okay, so the first one was when we have a difference of squares, that's going to be a minus, so a squared minus b squared is a minus b times a plus b. And then we had a difference, or sorry, a sum of cubes. And these were, this is only when we were looking at binomials. So we had the sum of cubes looked like a plus b times a squared minus ab plus b squared. And then the other formula was a to the third minus b to the third. So a difference of cubes was a minus b times a squared plus ab plus b squared. Okay, so those are the formulas that we kind of worked on. Now, just a note here that there is no sum of two squares, right? So note that we cannot factor a squared plus b squared. Okay, so for example, here, x squared plus 4, that's prime. Okay, that is prime. There's this common mistake here. There's a common mistake that, you know, people take x squared plus 4 and they say that it's x plus 2 times x plus 2. Well, let's FOIL that. Okay, so it's going to be x squared plus 2x plus 2x plus 4. These two combine to be 4x, and these aren't the same, right? Those are not the same. Okay, so don't factor them like that. But let's just do a couple examples here of those formulas. Okay, so again, let's factor completely. Okay, so example 1, let's do 25y squared minus 121. So again, with this 25y squared and 121, if you know your perfect squares really well, you'll recognize right away, oh, that's a difference of squares. I can use the first formula that we just talked about. If not, you know, you might have to try some things and you might mess up. But you know, what I would do is kind of make a list too of some of your perfect squares, right? 1, 2, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, etc. You know, and kind of compare to those numbers, right? Is it going to be a difference of squares? So for 25y squared, I know that 5y times 5y is 25y squared, or I know that 5y squared is 25y squared. And then I know that 11 times 11 is 121, or 11 squared is 121. So those are perfect squares. So we just kind of use our formula, right? And or the other way to do it is take the square root of those, right? The square root of 25y squared is 5y. So the 5y's go in the first slot next to the parentheses, and then negative 11 and plus 11 go there. And again, that is based on our formula right here. A squared minus b squared is a minus b times a plus b. So once you figure out a and b, that's what we did here. We are golden. So, and then let me do just one more example. I'll just do maybe a sum of cubes here. Let's see, what did I want to do? So 375 x to the 4th plus 3x. So factoring rules still apply, like we talked about a couple sections ago, that we want to try to find the GCF, right? And I know the GCF here is 3x, okay? So let's take out a 3x. So 375 x to the fourth divided by 3x is 125 x cubed. So this is going to be 125 x cubed plus 1 because 3x divided by 3x is just 1. And then this guy is our sum of cubes, okay? So I know that the cube root of 125 x cubed is 5x, or another way to look at that, right? If I multiply 5x 3 times, that's 125x cubed. So I know that, I know that my A, what's parentheses, equals 5x. And then what's the cube root of 1? Well, that's just 1. So B equals 1. Okay. So when we're doing this, when we're making our formula, I'm filling it in for what I have up here for my sum of 2 cubes, the second formula. Okay. So I do A plus B. So I have 5x plus 1. In this parentheses, by the way, I left the 3x. And I have A squared. So I have the 5x squared plus A times B. So plus 5x times 1 plus B squared. So plus 1 squared. And then we just simplify. So 5x squared, 5x times 5x is 25x. 5x times 1 is just still 5x, and then 1 squared is just 1. So this is the answer for that. All right, section 6.5. That was on our factoring strategies, or just factoring strategy. Okay, so I'm not going to do any examples in this section, but again, this was mainly a summary of the first 4 sections. Okay, so we have some steps here, right? We said step 1 is to factor out a GCF if possible, right? Step 2, right? I'll just say if possible. Right. Step 2, we had our binomial formulas. Right. Our binomial formulas. And so those were when we had the difference of squares, we had the sum of cubes, and we had the difference of cubes. Okay, so that's another thing to kind of look for when you factor. And then the third one was our trinomials. Okay, so we had, when it was just a 1 out front, so x squared plus bx plus c, or then the ax squared plus bx plus c. And then the fourth one was if there's 4 terms, okay, then we're going to group it. So these are kind of the thought process that you're going through when you're factoring. Okay, always think to factor out the GCF first. Then, what is it, 2 terms? If it is, it could be it could be a sum, or sorry, it could be a difference of squares. Or it could be a sum of cubes. It could be a difference of cubes. If it's 3 terms, look to factor it by the strategies that I showed you, right? If it's 1 out in front here, for this one, we just find 2 numbers that multiply to give you C that add to B. And then here was multiply A times C, and then find factors of that which add to B. And then if it's 4 terms, we most likely use grouping. And then actually not too much else here. So sections 6.6 and 6.7 were kind of combined there. And that was solving polynomial equations was the big topic there. So we talked about the zero product property and all that kind of stuff. So let's just do a couple examples here. So example 1, let's solve these now, right? We're actually finding what x could be. So let's do x squared plus 21x equals 5. So what I want to do is I just want to make everything on the same side here. So I'm going to move this 5x over, and it actually is a like term with 21x. So I'm going to put it under there and subtract. So I have x squared plus 16x equals 0. So the first step is to set it to 0. And then now what I can do is I can look for a GCF. So I can take out an x out of x squared plus 16x, and I have just x plus 16 left over. And then now this is where we use our zero product property, right? So I'm going to set x equal to 0, or I'm going to have x plus 16 equals 0. And when I solve this one, I'm going to get that x could be equal to 16 or x equals 0. So really, my answer is 0 or negative 16 for x, right? And we could definitely check this, right? So we could plug it back in to the original answers. I could do both, right? If I do 0 into all this, well, it's just 0 plus 0 equals 0, right? Just plug in 0 for x. Or I could plug in negative 16, right? So I can plug in negative 16. I'll need the calculator on this. But negative 16 squared, I think that is 250, yeah, 256. That's 256 minus, what's 21 times 16? That's 336. So does this equal negative 80, right? And 256 minus 336 is in fact negative 80. So it checks. And let's just go a little bit further. Thought this was going to be the end. Let's just do one more example for y'all. So we've got, sounded guy was from Texas or something right there. Definitely not the case. You guys know that I'm from Wisconsin, hopefully. So anyway, let's do x to the fourth plus 81 equals 18x squared. So again, the first step, we're going to get everything to one side. Okay. So what I'm doing is I moved 18x squared over here by subtracting it, and I put it between the x to the fourth and the 81, and then set this equal to 0, right? Now, what I can do is this is actually a perfect squared trinomial, right? Because I know that the square root of x to the fourth is x squared, and I know the square root of 81 is 9. So this is a perfect square trinomial. And so what does that mean? Well, that means I can break it up like so. Okay, I can just have that this is x squared, this is x squared, this is negative 9, and this is negative 9 as well, because I want a positive 81 when I FOIL, and then I want a negative 18x squared. And actually, both these are x squared minus 9s. Well, these are both a difference of squares. Okay, so this is a difference of squares, which is interesting because I can just break both of those up into x minus 3 and x plus 3. And I actually have that twice. And so I have two different things. So I have that this is going to be x minus 3 squared. And then this one is x plus 3 squared. Now this is a little bit interesting. I don't know if we've quite had one like this yet, but basically our answers then could be that, wait, so I'm gonna take this, right? I'm gonna set it equal to 0, and then I'm gonna take this one and I'm gonna set it equal to 0. Well, I would take the square root of this. So I would take the square root of x minus 3 squared equals 0, which is just x minus 3 equals 0, or x equals 3. And then this one, I would also take the square root, and maybe you could have seen this a couple steps ago on how this would have ended up. But this one is going to be x equals negative 3. Okay, so our answers here then are x equals negative 3, oops, x equals negative 3 or 3. And that's it. So let me actually get rid of some of this here. That is it for your chapter 6 review. So I would recommend kind of going back through some of this, working through some of the examples. Your practice test is going to be really key. It's going to look quite a bit like your actual test. So again, if you have questions, please let me know and we'll talk to you later.